So firstly, I will want to introduce about my company and their partner. Like Impulse Technology provide the cutting of next generation technology. They provided number of the softwares, and they have partnership with the Nano Academic Technology and Fleximegy. And we will be discuss about the both company and their softwares. Like Nano Academic Technology, they offer several softwares like NANODCAL, RESCU, and KiTCats. NANODCALs they generally use for the device and material simulations, and RESCU softwares it is used for the material simulation. And one of the new KiTCat, it is a spin qubit material simulations. And second one is the Fleximegy company, which will be used for the solar cell and OLED simulation software. They provide various softwares like SetFOS, LAS, FLOS. So we have that several software. And in the first day of this hands-on training, we will be discuss about the RESCU software and what is the actually objective of this RESCU software. They generally use for the material simulations. And overview of the RESCU software generally features, architectures, what is the actually capabilities like self-consistent field calculations, band structure, and density of states. And type of the system and simulation that supported, we will be tell. Introduction to the device studio. Generally, NANODCAL and RESCU operates at the device studio. They provided the GUI like interface walkthrough, structure, building tools, reserved for the DFT like density functional theory setups, create a silicon unit cells, perform self-constituted field calculation, and then we will move toward the analysis part. So some of that graph you can see, that is the band structures, and you can also see that the graph are between formation energy and k-point samplings. Like some of the top view and side view, you can see that type of structure you can create in the device studio and use of the NANODCAL and RESCU softwares, and you can create different structure and analysis as part also. In the RESCU softwares that work on the DFPT, density functional perturbation theory, each of the softwares work some of the theories, so they follow that. And we can also relax our structures. First, you can create at your new structure with provided user-defined data, and then you can relax your structures. That relax means you can optimize and what is the actually equilibrium type of structure that you want, so you can use that relax tab. And density functional perturbation theory overview, we can see they generally use for the phonon, dielectric constants, and force. And in the relaxations workflow, you can see convergence criteria, energy and force minimizations, relax a graphene sheet, one of the examples. You can also analyze force, energy convergence, and final, then you can get a geometry. Then you move toward the DFPT, like in the NANODCAL SCF, and in the RESCU DFPT simulation, and interpret that your results. So you can see one of the graph, phonon band structures, and then you can also see in the Raman intensity versus shift graph. So that type of graph you can found, and one of that electronic band structures, crystalline silicon and dope with silicon with the phosphorus. So that type of dope graph you can also found in the RESCU software, because we can analysis in the RESCU software's material properties. In the third day, you can see NANODCAL and 2-probe device modeling. Generally, in the NANODCALs, we can create 6-probe type device structures, but one by one, we will be show 2-probe device, 4-probe device, and 6-probe device that you can create. And what is the actual objective? That the same NANODCALs work as the device and material simulations parts, and their overview non-equilibrium green functions plus DFT formalism. That means you can work as the non-equilibrium states of the structures, and then you can move toward the device, molecules, and crystal parts. And in here you can see one of the device structures. That 2-probe that generally means one left and right electrode and one of the scattering regions, as you can see at the graph parts. And same as the graphene structure, you can see it is a left probe, left lead, and it is the same central region that also called scattering regions, and right lead you can see. So left and at the middle center points and right. So that one of the device that you can create. You can also increase as the buffer one by one. You can also increase the central regions. So you can create one of the device in the NANODCAL softwares. So that is the main difference between the RESCU and NANODCAL. RESCU generally used for the only materials, but NANODCALs used for the materials and device both. What is the actually transport parameter that you can calculate? Transmissions, local density of states, effective potentials. You can build 2 probe device structures in here, but you can also create 6 probe type device structure also. We can calculate transmission structure, density of state, effective potential, projected density of states, like various property like IV curves, photocurrents. So when you move toward the demo parts or hands-on training parts, then we will be see how we can create that type of device. It is just overview, and then we will be moved toward the 4th day, molecular and graphene based device simulations parts. Not only the graphene, we have the number of the materials, but in the graphene, nanoribbons, nanotubes, and armchair type of graphene, zigzag graphenes, you can also bend that type of device like this is the same you can create it in here. And same molecular device like benzene between metallic electrodes. So not only that zigzag graphene, you can also create molecules in here. Graphene based device like nanoribbon, heterostructures, and dope systems. You can also compute their parameter of the device, IV characteristics, local density of states, local charge distributions, simulate a benzene molecular junctions, create a dope graphene nanoribbon, and extract transport parameter properties. So that type of properties you can find at the 4th day of the sessions. So I will show how we can create and how we can analyze that type of properties. At the next, when you move 5th day, advanced device examples like PN junctions and magnetic tunnel junctions. Generally, at the simple device, you can use at the no spins, but when you move toward the magnetic parts, you can use the spin like general spins and collinear spins. So that options available in the NANODCAL also. You can also create a set of silicon PN junction, not only the silicons, you can use any type of materials which you want to create, and MOSFET FET that you can also use to create that NANODCAL softwares. We can align band alignment, potential profile, doping effects. That type of graph you can see, and at the same scattering regions, they have different materials. Magnetic tunnel junctions, that means spin polarization that we are talking about. General spins and collinear spins options are available. Perform XCF and transport simulations. That generally means before the analysis part, you first need to create one of the XCF files that known self-constituted field calculation. It created one of the script form, and according to that script or data, then we can analysis and we can calculate or simulate transport properties. We also analyze like spin result transmissions, that the same potential barrier profiles, density of states, magnetic moments, and build and simulate silicon PN junctions, simulate MTGs, and extract spin transport parameter as same. Generally, first we should know the nanoacademic technology, what is the company overview and who we are. Like company generally founded in 2008 by the Professor Hong Kong and Yuju. So McGill University. Our position is the molecular quantum transport softwares, which has developed for 10 plus years. We enhance material development through advanced digitalizations and modeling tools. Now we are determined to address the emerging sectors of the quantum computing revolutions. At the same, we have developed the QTCAD softwares. We have several unique tools to offer, and more development about like NANODCALs, RESCU, and QT-CATs. It's the some of the overview related to the RESCU softwares, real space electronic structure calculator. They generally have the some key features. You can see they work like the consomm package, every software that work, and key features you can see. They generally written in the MATLAB and C. We have some dependency of the MATLAB also because some of the parameter or data like IV curve and JD parameters. So you can see all type of data in the MATLAB, and you can plot all the graph in the device studio also as well. Focus on the large scale systems. They supported at the 20K atoms up to DFPT implementations, dielectric tensors, dynamic matrix, and we have calculates in the optical properties like dielectric permittivity and refractive index, Raman tools like tensor spectrum and intensity, advanced functional treatments such as a DFT plus hybrid and Howard-U terms like density functional or Howard-U terms that are used for the transition element analysis parts. And same we can analysis like density of states, projected density of states, local density of states, like band structure. So several type of analysis you can done in here. Non-linear optical susceptibility, spintronics that we have talked, collinear and non-collinear, general spins, phonon tools, and large scale CFSI solver. That one of the solvers to give the optimized or accurate results with the short times. We have some things that we have attached McGill University and RESCU. They have the approach for the material simulations. First, you need to import the data, then you need to move the RESCU softwares and DFPT implementations, and then you can analysis like choose opticals, Raman's, phonon density of state or band structures, and then you can analysis all type of the calculations. NanoAcademy technology generally have provided advanced tools. They generally have the user-friendly tools and smart analysis we can done in here at the some small period of the times, but calculation generally depend on the systems as well as the number of the atoms. We generally use this NanoAcademy technology softwares for the calculations, electronic, structural, optical, thermal, magnetic, electronic or thermal transports, and electron and phonon coupling. Some of the diagrams that we have attached, like you can see several papers, surface, complex materials, that type of interfaces, molecular device that couple with this, and two-dimensional device and carbon-based materials. So some of that structures we have attached from that papers. We have the several features that LDA, hybrid, collinear, non-collinears. You can see that the accuracies and partial extract correlations, assess with correlations, meta GGA, that generally the exchange correlations. We have the features that we can do analysis, symmetry, structure relaxations, band structure, band unfolding, density of state, Multi-can calculations, populations, linear functions. So that type of results, and after the analysis part, we can see generally the DFPT, how the response. So something that we have attached, electric field and atomic displacements, third order non-linear response, and solver that supported DFT and DFPT. Like you can see, ion, clamp dielectric constants, vibrational mode analysis that have supported phonon band structure, and density of states, bond effective charge. Many of the user want to ask how they work. So you can see in here, low frequency optical properties. They have infrared intensity, complex dielectric permittivity, and complex refractive index, energy loss, oscillator strength, and non-resident Raman spectrum properties like tensor, susceptibilities, and intensity. We have that separate tabs available, non-linear optical susceptibilities, and electron phonon couplings. You can see that matrix and scattering times and mobilities. So there's one of the toolbox, and what is the actually response function. So we have attached in here is one of the ion clamp dielectric constants, and they are the some of the accuracy benchmarks that we have supported. Some of the comparison with the different experiments that were done at the rescue, and what is the actually experiments. Large supercell simulations like diamond phonon density of states in given in here 8 atoms, and you can see the 64 atoms. Then we move toward the supercell type like 216 atoms. Same as the comparison with experiment of the dielectric permeability, refractive index, wavelength, and in the side hexagonals, ammonium nitrides. So you can see is one of the examples that we have already attached in here. So you can see some of the silicon nanowire studied by the DFPT methods. Like first we imported the silicons, then created one of the DFPT or script forms and provided various data, like first redefine that cells, and then we move toward the various analysis parts. Like if you choose the optical parameter, Raman spectrums, phonon density of states, so that user defined value you can choose. So my presentations parts are over in here, and my colleague Ujjwal, they will show the demo parts like hands-on trainings. So before the start of the demo, hands-on training, I want to ask all of them install the NANODCAL and RESCU softwares like Device Studio. So many of users typing in here, they have installed that rescue softwares. Yes, we will be provide the recorded sessions in the YouTube also. Okay. Now my colleague Ujjwal will explain about that NANODCAL and rescue softwares. So it is up to the Ujjwal. Wait 1 minute.
Thank you, Sai. Good evening, everyone. Just let me showcase the how to install the Device Studio software first. So my screen visible to all of you. Everyone received the mail like this. First, go to the Google Drive link. If anyone not installed, I'll show the procedure first. And click on download. Download anyway. And save any specific location. And go to the file. Here you can see Device Studio window, zip file. Right click. and extract all according to your specific path and extract. And also download the license file from the mail. You can see here license file. Download the license file. And copy the license file and go to the extracted device studio zip file. Here you can see device studio Windows. Click on this. You can see bin folder. Go to the bin folder and paste the license here. You can see here jwtech.lic file here. And you can also see the device studio application file. Double click to open the device studio. Here you can see. If you want, add to the pin to the taskbar also. I hope everyone opened the device studio software. Please confirm. Everyone open their device studio software. Okay. Here you can see the create a new project and open existing project. Click on create a new project and click on OK. And give some name of the project. And click on save. I hope everyone created their project. Here you can see this is a GUI of Device Studio where you can create your crystal material file and redefine your material file and model your structure also, create your device and simulate your structure and analysis also here. You can see at the top option, file option, edit option, view, build, simulator, window and help button. In the file option, you can see here you can see the new project option, open project, save project. If you want to create a new project, click on new project and give the name of the project and click on save if you want to create a new project here. In the same way, in the file, you can open your existing project also by clicking on this, click on open project and open your existing project using HPF format. You can see here, Raman Rescue, like you can open your existing project also. In the same way, in file option, you can see you can save project also with Control S, and in the new you can see you can create your device, crystal, and you can create your molecule also here. In the import option, you can see import local and import online to import your material file. At the below section, you can see properties where all properties of material you can see here, like the number of atoms, their coordinate also. And in the job manager, you can see the status of your script file, like in running condition, in queue condition, like this. You can see here, this is a toolbar option to model your structure, like deleting atom, replacing atom, move your atom, and mirror atom, rotate atom, and stretch the atom, and create your device, crystal, molecules, and measure the distance. Let's move to the file option and move to the import option. Here you can see import local and import online for the material, to import your material. Click on import local. You can see Our software provides some of the material files. You can see here organic material, 3D material, 2D material, 1D material, and 0D material. If you move in the organic material, you can see crystal and molecules. In crystal, you can see naphthalene. In molecule, different material are present. In the same way, if you move to the 3D material, you can see conductor, insulator, layer material, magnetic material, metal oxide, nobility material, and semiconductor. If you move in the conductor, pure metal, you can see the number of material file are present of the conductor. In the same way, for the insulator also, you can see diamond, NaCl, ZrCl3, and in the layer material, you can see the number of layer material are present. And in the same way for the magnetic material, you can see Fe, MnAs, and magnetic material are present. In the same way for the metal oxide, you can see zinc oxide, silicon oxide. And for the nobility material, you can see like perovskite, topological, and half metal. You can see the n number of perovskite material are present. And in the same way for the topological insulator. And at the below section, you can see semiconductor material also present. Let's import the silicon. Here you can see silicon material. Click. And at the below section, you can see our software support different material format also like XYZ, CIF, postcard, SCF input, molecular, PDB. Let's import the silicon first. I hope everyone import their silicon material in the GUI. Let me go through the again this step. Go to the file, import local. Here you can see the 3D material. In 3D material, you can see semiconductor. And go to the silicon. If you have different material, you can also import like in this format XYZ, CIF, postcard, and molecular, PDB. Different material format are supported our software. Let's move for the silicon first and click on open. It imported your material here. You can see your silicon crystal. If you move to the build option, here you can see build. In the build option, you can see redefine crystal. Click on redefine crystal. Here you can see ABC and UVW vector for the skating supercell or face centered and body centered. If you click on the face centered and preview, you can see the face centered structure of silicon. And click on the build. You can see the face centered structure of silicon. Again, I repeat the same process. First, click on the silicon first here and move to the build option. And here you can see redefine crystal and click on the face centered and click on preview to see the structure before building. You can see the face center structure of silicon crystal and click on build. We already done it. It comes with the name silicon redefine. You can see the face center structure of silicon crystal. Again, move to the build option and redefine crystal. Here you can see in the C axis, C direction, let's increase the number and create a supercell and preview. You can see it creates a supercell structure in C direction. You can also do in the B direction, like 2 cross 2 cross 10, and click on preview. You can see. Let's go for the only in C direction and click on preview and click on build. To zoom, you can use the mouse button and zoom your structure also. Again, I repeat the same process for redefining. First, go on the base centered silicon crystal, then go to the build option, then redefine crystal, and in the C direction, go for the 10 and click on preview and click on build. You can see here the structure. To see the different plane, you can click on the home icon. You can see here to the different view like XY view, XZ view, YZ view, YX view, and ZX view. To different view, you can click on the home icon and you can see the different view like XY, XZ, YZ, YX, and ZX. Let's move for the YZ. Sorry, XZ, YX, and ZX. Let's go for the ZX. I hope everyone completed up to here. If anyone have doubt, please ask in between. I hope everyone has been completed.
Yes, sir.
Okay. If you want to delete any atom, click on any atom like this. Left click of the mouse and select any atom. And you can see here the delete atom icon. Click on this and it will delete this atom. You can see. Again, I repeat. You can also redo undo using this. Select any atom and you can delete by clicking on this. If you want to delete multiple atoms, left click of the mouse and drag a box like this. It will select multiple atoms. Again, I repeat. Left click of the mouse and it will drag a rectangle box and select atom. If you want half atoms and full atoms, select and delete. You can see. Again, I repeat. If you want to delete only one atom, select any one atom and delete. If you want to select multiple atoms, left click of the mouse and drag a rectangle box and select. And click on delete atom. If you want to replace any atom with different atom, you can also do by selecting. You can see here A and B option given here with replace atom. Click on this. You can choose any element like nitrogen, and okay. You can see from silicon it will change it to the nitrogen. You can see. Again, I repeat, if you want to replace any atom with different atoms, click on any atom and click on replace atom toolbar and select any element like nitrogen, oxygen, and it will change this with silicon with oxygen. You can see here also the property. By clicking on this, you can see the property also oxygen, and all other elements are silicon. If you see all the properties of, again I repeat, if you want to delete only single atom, click on this atom, right, and click on delete atom icon here. You can see it will delete atom. If you want to delete multiple atom, left click of the mouse and drag a box like this. Like this, and click on delete. You can see it will delete it. And in the same way, if you want to replace any atom with different atom, you can choose like this and replace with other atom also, like nitrogen atom, and replace toolbar. It will replace with nitrogen. You can see also properties here, nitrogen and their Cartesian coordinates. I hope everyone is completed. Please confirm. If anyone have doubt, please ask. I hope everyone has completed up to here. If you want different material apart from this, like if you want material, your own material, you can also import by clicking import and import local. And if you move to the download option, I have some CIF file like aluminum nitride and click on OK. You can see. Okay, again I repeat the previous process. Select any atom to delete and click on this to delete any single atom. If you want to delete multiple atoms, left click of the mouse and draw a rectangle box like this, and it will select multiple atoms and click on delete toolbar. In the same way, if you want to replace this silicon atom with other atoms, click on this A cross B replace atom toolbar and click any element if you want, like nitrogen. Let's go for the nitrogen. You can see here it will change the color also, and it will replace from silicon to the nitrogen. By clicking on this, you can see also the properties here, like nitrogen, their coordinate XYZ Cartesian coordinates. I hope your doubt is clear. If you want to import your own material, like in CIF format, no sir, basically this is not called NANODCAL. Basically move in the redefining the C direction. If you want to import your own material like in CIF format or XYZ, you can also import by clicking on the import local. And if you download it from the Google, you can directly move here. And like you can see an united CIF file. By clicking on this, you can also import your own CIF file, XYZ file format in this GUI. Apart from that, here you can see import online. You can also import your material file from import online option by clicking on this. Click on import online. You can see it will create it import from material project. Basically, it will connect it from the material project API. Like if you type any material like MOS2, you can see with different space group, all MOS2 material are given here. Like you can select anyone, and you can see also their structure, their parameters like symmetry point, cell length, and alpha, beta, gamma, their angles, and click on add. You can see you can directly import your material from import online option. Again, I repeat the same process. Go to the file, then import, and below the import local option, you can see import online. Basically, it import your material from the material project. You can also type your material project ID also of the material file or type formula like silicon. Let's go for the NaCl and click on search. With different space group, it will show the material file. You can see, and their parameter are given also here, and you can move to the add section. I hope everyone has completed. Please confirm. Again, I repeat, there is a multiple option to import your material file. You can see in the file option, you can see import local. You can import your material from this material file project or your own material file in the download or any other path in the multiple format XYZ, CIF, postcard, SCF info, molecular, and PDB, and open. And apart from that, there is also option of import online. You can see import from material project. You can type your chemical formula or material project ID of their material file and click on search. With different space group, it will show. If the material are not present in the material project or in the folder of Device Studio or online also, you can also create your own material by moving on the file, then new. Here you can see crystal. Click on the crystal. You can see with different space group, you can see the n number of space group are present. And Brevis lattice, you can create your own crystal. Let's create a NaCl crystal here. Again, I repeat, to create your own material file, click on the file, then new, and then crystal option. Let's define their lattice. go for the 5.62 in the A. In the B section also, and in the C 5.62, and also angle 90 degree in all three, alpha, beta, gamma. You can see here P1, P2, and P3 are the fractional coordinates. Let's define the fractional coordinate. You can see here plus icon. Click on this. You can see by default carbon is choose. Clicking on the carbon element, it will open the periodic table. You can see. Click on the Na for sodium. Click on this Na. Basically, we create here 4 Na atom and 4 Cl atom. Again, click on the plus and again 4 sodium atom. You can see. And define their fractional coordinates. For first atom, let's go for the 0, 0, 0. And for the second, let's go for 0.5 at the P1. And for the P2 also. And for the third atom, let's go for the 0.5 for the P1 and 0.5 for the P3. And for the fourth atom, 0.5 for the P2. Again, I repeat, first define your space group, then Brevis lattice, then alpha, beta, gamma. After that, define your P1, P2, and P3 and their element. By clicking on this, it will open the periodic table and choose your element. First, I choose the sodium, 4 sodium atom, and define their fractional coordinate. Like for first atom, the P1, P2, and P3 are 0. For the second, P1 is 0.5, for P2 0.5, and for the third atom, P1 is 0.5, and P2 is 0, and P3 is 0.5. For the fourth atom, P1 is 0, and for the P2 is 0.5, and P3 is 0 for the fourth atom. Again, you can see the plus icon. Click on plus, and clicking on Na, choose chlorine. You can see here chlorine atom, and click on the plus icon to add 4 chlorine atom. You can see 4 chlorine atom, first, second, third, and fourth one. Again, let's give data for the P1 and P2, P3. For the P1, for the first chlorine atom is 0.5, and for the second chlorine atom, P2 will be the 0.5, and for the third chlorine atom, P3 will be the 0.5, and the fourth chlorine atom, all P1 and P2 and P3 are the 0.5. Again, I repeat, first move to the file option, then move to the new, then crystal. It will open this window and choose their space group. A different number of space group are present. I go for the 1P1, try clean it, and give the ABC value and alpha, beta, gamma. After that, you can create your own data according to your own data. If you want, create your own crystal and NaCl. I take some example. then I will create this. Like for the Na, 0, 0, P1 and P2, P3. And for the second atom, P1 will be 0.5 and P2 will be 0.5 and P3 is 0. And for the third, P1 is 0.5, P2 is 0 and P3 is 0.5. And for the fourth Na atom, P1 is 0, P2 is 0.5 and P3 is 0. And for the chlorine, you can see for the first chlorine atom, P1 is 0.5 and P2, P3 is 0. For the second chlorine atom, 0 for P1, P2 is 0.5 and P3 is 0 for the second chlorine atom. For the third chlorine atom, P1, P2 is 0 and P3 is 0.5. In the same way, for the last chlorine atom, 0.5 for all P1, P2 and P3. Click on conventional say and click on preview. You can see. If you move for the preview, primitive set, you can also go and click on build. You can see you can create your own material file using Crystal Builder. Again, I repeat, go to the file, then here you can see new option. In new option, you can see Crystal option. Click on Crystal. It will open the new window with Crystal and assigning their space group, A, B, C value, alpha, beta, gamma, and their fractional coordinate. You can create your own material file. And like this. And in the same way, you can also redefine these things in the C direction or A, B, C direction and create a supercell structure if you want. I think everyone has completed up to here.
Hello, sir.
Yes, sir.
Actually, we have given 4 Cl atoms, but here it came only 3.
There's some data value given error in the new option crystal. If you give in some value P1, P2, P3, you have to give in correct value.
Yeah, we have given same value as you have said. I think you are in your also 3 only. You can see.
Yeah. I take some wrong value. That's why it shows 3 atoms.
Okay.
I created random numbers.
Okay.
From literature, you can get the fractional coordinates and their space group, and you can create your own material file.
Okay.
In the file option, in the same way, in new option, you can see the device. If you click on the device, you can see left and right electrode structure, left, center, right electrode structure, bottom, top structure, bottom, center, and top structure, front, back structure, front, center, and back structure. You can create your 6 probe device also. For example, let's go for the LCR, left, center, and right. Click on OK. Here you can see left electrode, center, and right electrode. By clicking on 3 dot, you can see here, it will open the choose your material file, like material. And in the 3D material, semiconductor, let's go for the indium arsenide and click on open. And in the same way, for the center, again move for the material option, material folder. In 3D material, semiconductor, and choose silicon and click on open. Again for the right electrode, same material, indium arsenide, Click on this and move to the your device studio. Then material project folder, then 3D material, then semiconductor, then India arsenide. Open. And here you can see mismatch and click on the match option. You can also define the left electrode, center electrode regions and click on preview. You can see it will create a device structure like left electrode, right electrode, and center region. And their mismatch percentage also. By clicking on this, you can import your own material for the left electrode, right electrode, and center region. In the advanced option, you can also see their surface vectors, and you can assign also surface vector and click on preview. You can see. For the basic, let's go for the basic first. Match, click on preview and build. Again, I repeat, file, new, then device. You can see left, right, left, center, and right, bottom, top, bottom, center, and top, front, back, front, center, and back. Let's go for the XCR. Click on OK and import your materials. Like here, indium arsenide, by clicking on this and import your material. In the same way for the center region and for the right electrode, and click on match. And it will show the structure here. You can see it will create left electrode, center region, and the right electrode. In the file option, in new, you can see molecule option also here. Click on molecule. You can see it will open a new window with name molecule. I hope everyone open the molecule window. Go to the file option, then new, then go for the molecule. It will open the molecule window. You can see here the icon, ring fragment icon. Click on this. Choose first one. It will show here. And left click of the mouse and drag on this GUI. Again, I repeat, go to the file, new, molecule. It will open the new window with name molecule. You can see here the ring fragment option. Click on this and go for the first ring, benzene, and close this. And left click of the mouse on this window. It will show the benzene molecule here. By clicking on this, you can import n number of benzene molecules. Here you can see modify angle also. By clicking on this, you can also change the bond length. Like single bond, double bond, if you create your device structure, the lattice parameters should be matched. Like if you selected SNO2, then left, right, and center region, the center, the lattice parameter match should be matched. You can also change the bond also and change the bond length also between 1 and 2 atoms. And click on OK. Okay. In the same way, you can modify angle also by clicking on this. You can atom 1. You can fix atom 1 also and atom 2 also. And you can modify angle like this. In the same way, you can change their parameters like translate to translate atoms, and you can modify your angle. By clicking on plus, you can see you can also add atom. Like if you go for the nitrogen, click on nitrogen atom, and by clicking on this, you can replace with hydrogen with nitrogen. And you can also do this for this hydrogen atom and for this. And you can also add hydrogen atom for the nitrogen by clicking on this. By single click, it will add one hydrogen atom. By double click, it will add one atom more. You can see in the same way, one atom. And by second click, it will also second atom hydrogen atom. The same way, you can see. Click on apply data. You can see you can import your molecular structure here. Again, I repeat, go to the build, then molecule. From the build option, you can also open your molecule toolbar. And here you can see the big fragment. Let's move for the benzene. Select the benzene and close this. And left click of the mouse here. And it will import your benzene molecule here. You can see here for the modify the bond and modify the angle. You can change your bond also by selecting this and select the atom. It will open the new window where modify bond widget. You can change the bond type and bond length also. In the same way for the modify angle, you can choose atom and you can modify the angle in 3 atoms by fixing 1 atom, 2 atom or 3 atoms. And you can see here plus icon to add atoms. You can see. You can also see here last icon. This is it for the biomolecular material file. You can see different biomolecular material are present here. If anyone work on biomaterial, can also import it material file from here. and click on the apply data. And if you move your structure here, you can see here force field calculation for geometric optimization of your structure, molecular structure. Click on force. You can see there are multiple force field are present, universal force field and GFF, G chemical, MF 94 and double M F 94. Let's go for the cap. It basically optimize your structure. It will take some time. You can see it optimize the structure of molecule. In the same build option, you can see molecule 2D option. Click on molecule 2D. For the dope material, we create tomorrow for the doping materials projects. You can see here different multiple fragments are given here in 2D molecule. Again, click on this and drag a box, drag a ring. The same way, below the carbon atom, you can see draw single. Click on this and click on the node on the corner and draw single bond. In the same way, let's delete all this and again go to the build option, then molecule 2D. You can see multiple rig fragment are given here. Click on this, draw cyclohexyl and draw a cyclohexyl and again choose the draw single. You can see here below the choose element, you can see draw single option. Click on this and on corner, clicking on the corner, you can see you can draw single bond. Left click of the mouse on this corner and draw a single bond. I hope everyone is completed. Please confirm. If anyone have doubt, please ask. Again, replace CH3 with hydrogen. Click on the carbon atom. Now choose elements. Click on the choose element option. You can see it will open the periodic table. Click on hydrogen and close this and click on carbon only. Click on carbon. Again, I repeat, to replace the CH3 with hydrogen only, move here below the above the draw single option. You can see here choose element option. Click on choose element It will open the periodic table toolbar option. Choose the element like hydrogen and close this window, and only click on the carbon atom. It will replace with hydrogen. On carbon. I hope everyone completed up to here. You can also zoom. You can see at the property section, you can see the bond arrow frame also, atom default, bond default, and their visibility, grid, lone pair, and radicals. And click on apply data. You can see it will create 3D molecular structure using 2D molecule toolbar option. Again, move for the force and click on universal force field. Not for the universal force field, go for the GFF. Again, I repeat the 2D molecular structure option. Move to the build molecule 2D. In the ring fragment option, you can see draw cross cycloaxyl. Click on this, drag, and you can see here cross single line, cross single. Click on the corner and cross single one for all nodes. And to replace CH3 with hydrogen, click on choose element option and click on hydrogen. Again, click on the carbon, it will replace hydrogen in the same way for all CH3. And click on apply data. After apply data, it will show the structure and go for the force field calculation and go for the GAFF. In the build option, you can see the graphene nano ribbon option here. Click on this. It will open the graphene nano ribbon window type. You can see here site A and site B. You can see carbon is selected. If you click on this, it will open the periodic table. If you want different nano ribbon structure, you can choose. By default, carbon is selected. Let's go for the by default. And you can see site B also is carbon. And you can see also the bond length in between 1.42 angstrom. And here you can see passive dangling bond with hydrogen atom, basically hydrogen passivation. Click on this, and structure type will be 2x2 or zigzag graphene, and click on preview. You can see. And click on build. It will create your zigzag graphene structure. Again, I repeat the same process. Go to the build. Then in build option, you can see here graphene nano ribbon structure. Click on graphene nano ribbon. And here you can see carbon is selected by default. Let's go for the default one. If you want to change, click on this. It will open the periodic table. Choose according to your uses and click on OK. And then for the side view also, and assign bond length. After that, hydrogen, if you want hydrogen passivation, click on this and click on preview and click on build. If you want to redefine this 2x2 nano ribbon, zigzag graphene nano ribbon, click on simulator, build option, then redefine crystal. In the C direction, go for the 10 and click on preview. You can see here, it will create graphene nano ribbon structure. And click on build. To see different view, you can see home icon. Click on this and click on every view like XY to see the different view, XZ, YZ, YX, and ZX view. Let's go for the ZX view. You can see. Here you can see the last icon. It basically convert to device option. If you click on the left electrode, right electrode, and preview, it will create the device structure by defining the left electrode and right electrode region. You can also change if you want, like go for the 4 and 4 and click on preview. You can see it will create graphene nano ribbon device structure and click on build. In the same way, if you move for the build option in the graphene nano ribbon, to create armchair build option, then here you can see graphene nano ribbon structure. Click on this, and by default carbon is selected. If you want different elements, by clicking on this, you can change for side A and side B also, and you can also change the bond length. It is user defined data basically. And if you want hydrogen passivation, click on this icon and go for the N cross, N is equal to 2 and M is equal to 2 also, and click on preview. And again go for the build option. After build option, it will show the structure like this. To move your structure like this, right click of the mouse and you can move like this. Again, go to the build and redefine system and redefining the C direction like 10 and click on preview. Then now you can build. After creating, redefining, you switch to the convert to device if you want, and click on left electrode, right electrode, and you can also change the length of the left electrode and right electrode, and click on build. This will show the structure like this: left electrode, center region or scattering region, and right electrode. In the same way, in build option, you can see graphene nanotube. You can see. By default, carbon is selected. If you want to change, you can choose. Go for the default one this time, and the bond length also 1.42, and the structure will be 2 cross 2. Let's go for the 3 cross 3. 3 and preview. You can see it will create carbon nanotube, a graphene nanotube, and click on build. And in the same way, build option, redefine, and in the C direction if you want, you can redefine your carbon nanotube. And click on build. Again, I repeat, first go to the build then graphene nanotube, then go for the 3x3, then PPU, and after that, to show the structure like this, go to the build, then redefine, and in C direction, go for the 10, and then 50. It's basically 3x3 graphene nanotube structure. Again, let's go for the 5x5 this time. In build, graphene nanotube, choose here 5 and 5 here. Click on preview, then build. Again, I repeat, build graphene nanotube and tube 5x5, then 5x5, here 5, and I'm also be 5 and preview, and then build. After that, go to the build, redefine crystal in the C direction, 10, and click on build. You can see this one is the 5x5 graphene nanotube, sorry, 5x5 carbon nanotube. Click on the 3x3 graphene nanotube and left click of the mouse and drag a whole box to select all atoms. Again, I repeat, left click, go on the 3x3 graphene nanoribbon tube. Here you can see 3x3. Left click of the mouse, select all atoms and Control C. I hope everyone is selected. Left click of the mouse, select all atom, Control C, or copy. Left click of the right of the mouse and copy. And go for the 5x5 graphene nanotube. Click on home icon and paste your 3x3. You can see here. Again, I repeat, go to the 3x3 carbon nanotube. Select, go to the 3x3 nanotube. Left click of the mouse, draw a rectangle box, Control C, and move to the 5x5 nanotube and paste here. And again select this 3x3 nanotube, all, and here you can see here center option. Click on center. You can see it will create concentric nanotube structure like this. The 3x3 one and the 5x5. In the build option, you can see multiple options are given like interface builder, fill junction with atom, CAD to atomic, surface slab. You can also create your surface, and graphene nanoribbon, graphene nanotube, nanotube structure, tube vector drawn, and disorder graphene light. Let's go for this interface filter option. Click on interface filter. To create heterosection between two different elements, two different material files. Go to the build, then interface builder. You can see structure and structure. You can see 3 here. By clicking on this, in 3D material, let's go for the conductor this time, then pure metal, And let's go for the silver design and open. And surface order will be checked. And then choose the structure B, material file. Click on 3 dot folder. Click on 3D material, then conductor, then pure metal, and choose gold. And click on open. And cross and range will be 6, and M range will be also be 6. You can see here the match option. Click on match. You can match percentage also, the atom number, total number, angle, rotation, area, strain, UV, and their theta value. You can see strain range also 100%. If you want strain surface for the both surface, first surface, second surface, and for the both surface, it totally depend on you. Click on preview. You can see it creates heterostructure between two different materials. Again, I repeat, first go to the interface builder option, then choose the material file by clicking on this, and you can also change the surface order if you want XYZ. And in the same way for the structure B, and cross N will be 6 and M will be also 6, and their rotation also. And click on match, then preview, and move to the build option. Through interface builder, you can create heterostructure between two different material with same their lattice pattern should be matched and their angle. In the same way, in the build option, below interface filter, you can see CAD to atom. Click on this. It will open the new window with name CAD to atomic. Click on this and draw a box. Again, click and drag a box like this. And click on calculation. You can see here, it will open the new window with structure, select, direction, and length. You can create multiple material file heterostructure. You can choose any structure. Like, go for the 3D material, then conductor, pure metal, then gold, and the same way go to the material, 3D material, conductor, pure metal, then go for this center region, this silver, and again go for the gold, the third material, 3D material, conductor, pure metal, sorry, choose the gold option. Material, 3D material, conductor, pure metal, and gold. You can see also the direction here, and you can assign the length like 0.5 nanometer, 1 nanometer, and 0.5. And will be 6, and will be also 6. You can also change according to your data and rotation, their strain range and strain surface. and click on preview. You can see. By defining CAD to atomic structure, you can create multiple heterostructure with different material file and click on build. Again, I explain build, then CAD to atomic. Clicking on this, you can create different material. You can create heterostructure like this one will be silicon, gallium arsenide, indium arsenide, and with gold option. You can create heterostructure like this and go to the calculation and choose your material file here. After that, define the length of our material file and click on preview, then build. Again, in the same build option, you can see the surface slab option. Here Miller indices are given. You can see you can create your slab structure and add a vacuum also, and the slab thickness also. You can see including slab, their thickness and their vacuum. You can build. Again, in the build option, you can see symmetry option. It basically tell about the properties of your material file, like periodicity, their name, their space group, their long name, crystal system, and their crystal class, and their operators also for any material. And in the same build option, you can see standardized cell. It basically convert your this cell into primitive cell. Click on standardized cell. You can see it convert to the primitive cell. I hope everyone is completed up to here. Anyone have doubt? Please ask.
Hello, sir.
Yes, sir.
When I'm creating the heterostructures, let us say 2 layers.
Yes, sir.
Between these 2 layers, if I want to make some twist,
What, sir? Please repeat.
uh, creating the heterostructure,
Yes, sir.
let us say one plane is silver and one plane is gold.
Hmm.
So if I want to create some twist between them, so how it is?
You can also do this.
Yeah.
Let me show you. Select any one of that atom, and
Okay.
here you can see the move option. You can move your atom along the X, Y, Z axis and screen view also. By defining the distance also. And you can modify angle also here. And if you want to create your device, you can also bending of device also possible in our software.
Okay.
Anyone else? Yes, sir, we provide a recorded video. For the graphene nano ribbon, move to the build and go to the graphene nano ribbon. And according to your zigzag graphene, armchair graphene, you can create and change the bond length also. And click on preview. Then build. After that, go to the redefine and you redefine your graphene nano ribbon structure. And to move your atom, select any atom, and you can see here the rotation option also given. Rotation and move option. You can see rotation along the screen vector XYZ axis. Let's go for the screen vector. You can see it will change the angle. And you can also follow the documentation. Type Nano Academy. nanoacademy.com. You can see the multiple software NANODCAL QTCAD. At the below section of the website, you can see here the documentation and tutorials. Click on this. You can see the NANODCAL RESCU and QTCAD software and their tutorials, theory parts are given here. You can also follow this. I'll give the link in the chat box. And to learn about the GUI of the Device Studio, click on the help. You can see getting started with Device Studio. Click on this. Click on help, getting started with Device Studio. You can see it will open a HTML file. Click on open. And translate into English. You can see here the Device Studio GUI. Like material database, how to import material, create 2D structure, complex 2D structure. You can see here 3D molecular structure like this, and create device structures. Click on the help option, then getting started with Device Studio. Anyone else have a doubt? Please ask. I hope everyone follow the steps to create a structure, their crystal, import material. In today's session, basically we go to the toolbar GUI of the Device Studio. In tomorrow's session, basically we go through the RESCU software, which is DFPT for the material simulation software, and density function perturbation theory, where we can find band structure, molecular potential, effective potentials, phonon, optical properties, dielectric, Raman spectrum. This type of data we can tomorrow find.
Hello, sir.
Yes, sir.
So after creating this, whatever the 2D images here, 3D images, can
Yes.
we save it for the image file
Yes, sir. You
like
can.
TIF, JPG?
Yes, sir. Let me go to the molecular protein. And like that. Save this by clicking on this. In export option, you can see multiple image format are supported, like PNG, PMG, JPG. You can draw structure here and go to the file, then export and give your file name. And in any format, you can save your 2D molecular structure.
Same for 3D also.
Yes, sir.
Okay, okay, sir. Thank you so much.
Thank you everyone for joining the session. Yes, you can create multiple in-film heterostructure using the CAD to atomic tool and multiple build option tools. You can create heterostructure of different various orientation. Thank you everyone for joining the session.